surface or the data so that a given location, either a single vertex or a region of interest, corresponds across different subjects. I'm not really talking about Human Connectome Project here today, but they do have another surface registration algorithm that you can use on top of this called MSM, and that's by Emma Robinson's group, so you can look that up later if you're interested. But it works better with FreeSurfer. Okay, so why is service-based registration important? As I said, it allows regionally specific statistical analyses across different subjects. For example, developmental trajectories, aging, disease versus control, or training tasks. So how do I use CIVET? So as we already hinted at, for beginners and up, we do recommend you use CBRAIN, and Christina coming up next will give more detailed examples of how to work your way through this on CBRAIN, and I know there's a hands-on tutorial after that. If you're an advanced user, you probably still should use CBRAIN, but it's also possible to use the links command line, and there's the files are on GitHub, but this is pretty advanced and there's a bit of tricky installation, so I'm not going to discuss that today. Okay, how do I check quality control output? So if you're using CBRAIN, you're going to look in the verify folder, but I think you can also click show displayable contents. And there's a lot of images in there. I'll show you some examples. One quick note beforehand, if your CIVET run crashes and doesn't get to this stage, it's probably due to self-intersections of the white surface. And this is an issue with the quality of your input scan. So it means if you simply rerun CIVET over and over, it won't solve the problem. But I'm going to walk you through an example of good quality control output. And at the end of this presentation, I'll give a link to some other older documentation where we show examples of bad quality control, and then you can compare. But here's an example of what it should look like. So after we're running, we're going to look at the verify image. You can check for motion artifacts. So instead of your image being nice and sharp, you might see rippled or curved lines. Again, you don't see it here because this is a good example, but this is the image that you would see it in. You can check the skull mask, which is the red line here. You can check the classification and the volume of white matter and gray matter, and also the overlay of the surfaces. On this image, especially at this bottom row here, you want to pay careful attention probably to the temporal pole. Sometimes it's cut off, or the meninges near the central gyri, because sometimes they're picked up by accident. For the clasp image, at the top, you can check the white surface for masking errors. If you see like a piece of skull attached to the surface, motion artifacts, it might look kind of jaggy, and there might be bridges connecting across the gyri that look unnatural. For the gray surface, you can check for underexpansion. This often happens in the frontal lobes or temporal lobes. It might look kind of thin. Cortical thickness maps, we're checking for poor N3 correction of non-uniformities. And this range is 0 to 5.5. Anyway, I know it looks all green right now because it's pretty good, but if you see like hot spots, hot colors, this could be a problem. It could be indicative that there's something thicker, it's too thick. It could be at the temporal poles in particular. Okay, I know this image also looks green, but it's actually a different plot. It's a Laplacian image. So value of 10 indicates perfect convergence. If you see high colors in the high spectrum, like red to white, that can indicate vertices that are overexpanded too far outside the peel surface. In contrast, colors that are low, like blue to black, could indicate vertices inside the cortex, so under expansion. So again, this is a good image, but maybe see a little bit of blue there. So there's an example of a little spot that is underexpanded. Okay, for the atlas image, we're going to check this basically is a way to check the quality of the surface registration that I was talking about to the average surface. So this is a simple Lober parcellation. There's also an AAL available, we'll describe in a moment, but the basic Lober one is the default. And you can pay special attention to the border between the frontal and the parietal lobes, the central sulcus, which should be pretty clear to most of you. So between the green and the blue here, so make sure that's in the right spot, and that's your first clue. And we also have these painted lines here. They should be on the gyri and not buried in the sulci. Okay, this is for surface-surface intersections between the gray and white surface. If you see pink spots, that's a bad sign. I don't really see pink spots here, so that is a good sign. Also, the top here does list how many. So we've 0 on left and 7 on the right. So it's just a handful. Like this is a good scan. I wouldn't worry. But if you have a few dozen or 100, you have a problem. You'll probably see pink everywhere. But these could indicate errors in masking, tissue classification, or surface extraction. Okay, so many of you might be wondering how is CIVET different from FreeSurfer? And I think we're both going to touch on this a little bit. And I'm not really here to promote FreeSurfer, but I wanted to do a little bit of a comparison. So both are automated MRR structural pipelines. They both have very long histories, over 20 years, but they are developed in different groups or software ecosystems. They use different file formats and they have different average surfaces. But they share many of the same general principles and stages, such as volumetric registration of the input T1 to stereotaxic space, inhomogeneity or non-uniformity correction, N3 or N4. I think a lot of people ask about this, so I'm just going to touch on it very quickly. CIVET uses the MNI N3 algorithm, and in CBRAIN, you have to actually choose these values. Like, it doesn't have a default because they want to make sure you think about it. But if you have a 3T scan and it's relatively modern, it's probably you're gonna start probably around 125, the higher end of this range. If that doesn't work well, or if you have an older scan, you can use a little bit lower. And there's a few other recommended values there. FreeSurfer now uses by default ANS N4, but they also have options for ANS N3 or also the MNI N3 like CIVET uses. Okay, they both have brain masking. They both have the marching cubes tessellation of the white surface, the video I showed earlier, or the animation rather. It may not matter to you, but I think it's important to know that CIVET has a fixed number of vertices per hemisphere. So they call this 40K low res and the 163K is high resolution. FreeSurfer for each individual subject actually has a variable number. So I'd say it's roughly about 150K, but this is different than the average surface, which is fixed for both at 163K. They both produce some outputs that are roughly similar, but with different atlases, or some in common, some not. There's a volumetric parcellation. CIVET produces animal if you choose that option. And FreeSurfer has, I think Christina will talk about more of these later, the ASEG or the white matter park, and I'll show images of these later. It also has surface registration, as I mentioned, to different group average surfaces to do vertex-wise analyses. CIVET uses the MNI ICBM 152 surface, and FreeSurfer has used FS average for a very, very long time, maybe since the beginning. This is also called the Buckner 40. So the numbers mean that CIVET's atlas used 152 subjects to average, and FreeSurfer used 40. And I'll show you in a moment. So after registration, you can also have surface parcellation with these different atlases. So CIVET, we showed Lober before, which is the default when I showed the QC image, but you can also choose AAL or DKT. And FreeSurfer has a range of atlases as well. I'm not going to show all of them, but just the general concept. So here's an example of CIVET's volumetric atlas animal, which is from Louis Collins' group here a while ago. I'll go back to my screen. Okay. Here's the same idea for FreeSurfer. So it produces an intermediate step as the aseg.mgz, and then later on it produces a more detailed white matter park.mgz. So I know I'm just showing 2D slices, but these are actually 3D images, of course. Okay, and as I'm alluded to, we're going to talk a little bit about the average surfaces. So they use different average surfaces. Generally, they look smoother than an individual surface because they are an average of subjects. The more average together, the smoother it might look. So even though they look kind of similar and smooth, they're not the same. They have different subjects, different vertex layouts that are incompatible. So you cannot simply process CIVET data and put on FreeSurfer's FS average, nor vice versa. So if you know in advance you need a particular atlas defined in a particular software, it's recommended that you use the same software. On the bottom, I kind of added another bonus thing from the Human Connectome project. Again, not really talking about today, but in the last few years, they've been promoting kind of an extension of FS average, which is called FSLR, and it also has incompatible vertex layout, but there are registrations between them. And there is an important atlas called the MMP from Glasser's group. Okay, so here's some example of surface atlases. CIVET, so following surface registration, on the left, we have the AEL atlas, which is defined on the ICBM MNI 152. And again, following registration, then we can project it or resample it onto an individual subject, which I have here on the right. And it's the same thing for FreeSurfer. On the left, we have the DKT atlas defined on FS average. And following surface registration, we can resample that data onto an individual subject on the right. I just want to show a simple schematic of what all these terms mean if you're not familiar with them, especially with CBRAIN, which I'm not going to spend a lot of time on because I know other people here are. But the required input type is a little bit different between CIVET and FreeSurfer. So CIVET takes MINC, and FreeSurfer takes NIfTY or MGZ. If you have the wrong file type, you can convert either on your own workstation if you know how, or some of these conversion tools are in CBRAIN, and you can use them there. And then Of course, you submit to the automated structural pipeline of your choice, CIVET or FreeSurfer. These could be done on a workstation, but here we are promoting CBRAIN, but you have a choice of how to process it. And normally then you would download this data and do statistical analyses, although maybe now there's Jupyter notebooks I saw in the last presentation. So maybe there are more options. But historically, we would download them. And to do group-based statistics, we'd use SurfStat, which is in MATLAB. And my understanding now is that there's now BrainStat. I haven't personally used it, but this is a Python wrapper around SurfStat produced by Boris Bernhardt's lab here. There's also R, or your own scripts or tools. Okay, where can I find documentation or help for CIVET? There's many places. There's a few different perspectives, which I think are all valuable in their own way. From the developers, we do update this first link recently enough. Or you can just Google CIVET M&I, and we have lots of examples of quality control and how to export to R and SurfStat. But again, we created this before BrainStat, so you would have to separately look at their own documentation. A lot of what I'm saying today is based on updated from these 11-year-old slides. But I do have more examples there of quality control that failed, so you can compare good versus bad and get a better feel for it. If you have general questions, you should probably ask me first. There's my email address. If you have advanced questions, you should probably still email me first, and then I'll send to Claude if I don't know the answer. But if you know him already, you can try him. If it's CBRAIN particular or basic questions, they can probably also help you. So they have a getting started guide, they have a support forum, and an email address also for help. And the last perspective also would be from an expert user, like Christina here is giving the presentation after me. I kind of threw in this little bonus thing about high-res options because I feel it's not talked about often enough, and this is the direction things are going. So the standard resolution MRI is usually assumed to be 1 millimeter cubed, and this is the case for both CIVET and FreeSurfer still. But higher resolution data is becoming increasingly common. You might already have it, especially if you're using 7T. So if you have high resolution data, you should be careful because if you just use the default settings on these pipelines, it will downsample your data. So if you want to preserve the resolution of your data, you have two options. They're different in each software. For CIVET, you actually choose a template size. It could be 0.5 or 0.75 millimeters. And then regardless of the input resolution, CIVET will process at that template size. So even if you input actually 1 millimeter, it will then upsample it to process at the size you choose. And this is, I think, even recommended at this point. FreeSurfer is a little different. You have to use the high-res flag when you submit Recon All, and it will process at the identical resolution of whatever your input resolution is. But you have to be careful because if your input isn't isotropic or exactly the same resolution and dimensions in all 3 dimensions, it will either resample or pad your scan to make it that way. So you have to be a little careful to make sure that it's not doing weird things to your input. So, okay, additional resources. If you use CIVET, we have a whole list of them here. Also, the references.txt that comes out of CBRAIN has the same list of references. There are a lot of large data sets already analyzed with CIVET. These are just some of them: ABCD, ADNI, UK Biobank. I think some of these are on Loris if you're interested, or you can ask CBRAIN where to find them. And new on CBRAIN, there's a few non-human primate versions of CIVET available. You just have to ask on CBRAIN for permission, and they can change the settings on your profile. There's CIVET Macaque, and there's CIVET Chimpanzee. These I cannot help you with, so if you get stuck, you have to email Claude directly. There's his email. So that's it. Thank you. I think it's probably good Christina goes next and do all the questions after.
Thanks, Lindsay. Do you prefer the open, like the power? I say your, even the PF works fine. Less complicated. Actually, actually, let me just go back. That doesn't look good. Just wanted to do full screen. I'll have to download it, I guess. Now, where's the full screen on this? Using a plugin, so I don't know which setting is for full screen. Are you okay if we just use it this size then? We'll share the screen with it. It's not perfect, I know. Put this bar out of the way. Arrow keys left and right should work.
With this key.
Yeah, the arrow keys should work good.
Okay, good.
Christina is research associate at Hôpital at Sacré-Cœur in Montreal.
Yeah.
I think you work in regarding sleep medicine.
Yeah, I'm working in sleep medicine, and I'm with Shadi Rael now. We're like in a brand new lab, like just 1 year ago, began 1 year ago. And yeah, so I'm gonna talk to you more like as a user point of view. So it's really like my preference and how to like use the CIVET and FreeSurfer on CBRAIN when you have like only T1 and with really just a few basic knowledge. So I'm gonna go so quickly on what is CIVET and FreeSurfer because Lindsay already covered that, I think, pretty well. And I'm going to focus a bit more on how to use CIVET and FreeSurfer on CBRAIN. And finally, I'm going to give you just a brief summary table. I think this is gonna summarize a bit what I told you and what also Lindsay told you a bit between the difference between CIVET and FreeSurfer. Because yeah, it's often a question I have like from student or new user. Should I use CIVET or FreeSurfer? Because they basically gonna give you like really like the main measure like cortical thickness, volume, and surface area, which are like the main measure used in a lot of study, in a lot of paper. So yeah, so Lindsay already covered that. Just to remind you that if you want to have like more details about like how CIVET is working, and this is pretty much also the basic for FreeSurfer, like the rebuilding a white surface and a gray surface, then just go see our slide. Even though if 10 years ago, it's still like really useful and really in detail. So if you need any detail about the QC, really go see our slide. So, Lindsay already covered what the CIVET is. So it's really like not to have to do manually the processing of your T1 to recreate yourself like a white and gray minor surface, but usually as a user point of view, you use it because you want one of these three measures, like cortical thickness, surface area, cortical volume, and also like CIVET gonna give you like a few measure in bonus if you want, like gerification index, and you can also choose the VBM. It's mainly for cross-sectional data, though you can try to put longitudinal data in CIVET, but CIVET gonna still like consider it like it's like different subject. So maybe if you have longitudinal data, CIVET is not the perfect solution for you. And yeah, I just put like what the surf stat output look like. So usually, as a user point of view, like what I did is like when I use CIVET for processing, then I get the data I get the cortical thickness, for example, and then I put that in surf stat, which is like Lindsay mentioned, like it's a MATLAB toolbox. And that you can have like a p-value brain map, you can have like t-stat map, you can have like cortical thickness map, and they always gonna give you like this nice image output, and it's like really easy to use. Everything like is basically already there and made for you. You just have to follow the step on the MATLAB toolbox. So a FreeSurfer is gonna give you basically the same output, cortical thickness, surface area, cortical volume. They're gonna give you also like some other measure like curvature, but it's more rare that people are gonna use this one. They're gonna also give you, it's gonna also give you in addition the subcortical structural volume of the around 7 subcortical region. So this can be useful if you want both at the same time, the cortical measure and subcortical. And you can also have like the measure of the brainstem and cerebellum in FreeSurfer. And they're gonna give you also like just by default, like Lindsay mentioned, like the region like in the all the measure with the DK atlas, which is like 68 cortical region. And it's a bit like CIVET, like I think it's also good when you have like a lot of subject. And but the QC takes a longer time though with FreeSurfer. So usually like if you have a lot of subject, like thousands of subjects, it's better to have like kind of a specific QC protocol. Like for example, like Enigma create like a specific protocol to QC the region of the DK atlas after you process it with FreeSurfer. If you want to do, you can also do manual QC in FreeSurfer in the sense that you can manually correct the image if you have problem in it, which is not the case with CIVET. So, but in this case, I recommend it only if you have like maybe a couple of 100 subjects, because it's really like time consuming. Or what you can do is also like just find out the outlier and decide to manually correct the outlier if you want. And FreeSurfer, you have a version for cross-sectional data and also longitudinal data, though I mainly use the cross-sectional FreeSurfer version. So both of them, CIVET and FreeSurfer, have basically the same workflow. I'm gonna go like really quick because Lindsay also covered it. So you put your input, then you run it in CBRAIN. So you launch either CIVET or FreeSurfer. Then CBRAIN gives you the output. You don't need to know what it's doing, basically. You just need to get the output. And after that, you can do, you can download it on your computer, which I mostly did. You can also do it on CBRAIN, but I think it's easier to do it on your computer. So you download like the QC, you download the output, and then you do the QC for CIVET, which is usually just pass or fail if it's bad or not, bad or good. And you can do also the QC for FreeSurfer, which is, you can also do like bad or fail for FreeSurfer. But I think like if you have only like a few subjects, it might be also worth it to do some correction manually. Okay, so on CBRAIN, how do you run CIVET? So first, you upload your main file. If you don't have main file, then you need to change your Nifty in Ming or your DCOM in Ming. And then you need to change the name. So it's like, it's in this form, like prefix ID T1.mnc. And then this is like optional. You can decide not to pre-process your file first. Personally, I find that if I have like really, if I have T1 for a really different data set, it might be worth it to pre-process it like with really like, it is 3 sample step, like you can use like this website, you can go on this website and they tell you what to do. You have like a bash script, you run it, and it just kind of homogenize a bit your data, put the origin at the same place, and put also a few parameters. So like you had less, usually when I do that, I have less T1 that fail when I process with CIVET or FreeSurfer. And also sometimes some T1 can fail. And then I do this pre-processing and then it passes. So sometimes it could also like resolve some problem. And then when your file already, then you can put it, you upload it in CBRAIN with the SFTP. So Lindsay put really in detail how to do that. Like you have even the command line. So like after you create your CBRAIN account, you have a specific command line with the port 7500. It's slide 23 if you want the command. And then once you upload your file in a SFTP provider in CBRAIN, then you have to register your file and move them in your project. So in CBRAIN, you can create different projects, which is called the main store. And then you need to say, okay, this file goes in this project. And then you select, once you have your file in your project, you select them and you just choose launch CIVET. And it's as easy as that. The more tricky thing is maybe to choose the parameters, which usually the one by default are fine, I feel. There's only the entry spline distance that you really have to put. So it's going to be empty and you have to put a number there. So, but 100 for 3 Tesla, T1 is good. 150 for 1.5, like Lindsay said, I find that it also works really well. And I test different number, and personally, I didn't see much difference just by changing a bit this number. But it might depend on the data set you're using. So yeah, and after that, you have to choose the thickness method. So you have T-Link, T-Laplace, or TFS, which is supposed to be TFS is supposed to be the one that looks the most like the output of FreeSurfer. But they're also really similar to TFS and T-Link. So it's practically the same thing. T-Laplace gonna give you, there's some people that say it might gonna give you a more biologically possible cortical thickness, because the T-Laplace is gonna measure different trajectory between your white matter to go to your white matter to your gray matter. And then it's going to average all these different trajectory. And T-Link's going to only measure the shorter distance basically between your white and gray matter, which might not always be the best solution to measure cortical thickness, especially in the temporal lobe. So be aware of this. Personally, sometimes I try you can put both T-Link and T-Laplace and see if your results are different, or if your results are current with what you think you're gonna have or you should have. And also, and then you need to choose the smoothing, the kernel size. I find that most people use a 20 millimeter, which seems to be okay-ish. But if you want to be more precise, you can also try 15 millimeters, or if you want to smooth more, you can try 25, 30 millimeter, but 20 millimeter works well in general. And then after you launch CIVET and you got your output, then you have to select all your output and you run a CIVET combiner, which is going to combine all your subjects together. And then after that, you choose an output that runs CIVET combiner, and you run the CIVET QC tool to have the QC table with all your subjects together in CBRAIN. So, and this, will I continue? But yeah, this QC table is basically gonna allow you to verify if you have outlier really quickly. So it gives you a bunch of measure, and I think they even put color. And when you have red color, then you can say, okay, this subject seems to have a measure that is out of bound. So you can just look really quickly at your outlier like this on CIVET. But another way to do the QC with CIVET is the CBRAIN is gonna produce HTML file, and then like Lindsay told you, then you're gonna you can look at all this HTML file. I'm gonna go through that because Lindsay already did. But personally, it's really long to look at all of it. But I look mostly at these two main parts. First, to verify really if the segmentation between the white and the gray matter is well done. and also like the reconstruction, also the PR surface, like because it's gonna tell you really quickly, like if it takes like meninges, like a part of bone part, like if you look at it. So usually this is really like I pass more time on this one and the other I just scroll really fast. And yeah, and some tips also for the QC. Since like I guess it's quite fast to do the QC, I think usually like we'll like use 2 independent rater and both rater gonna say like pass or fail for each subject. Then we met and we discussed only the subject that we didn't agree on. So it could be like a good way to do the QC for CIVET. And I think it's really common to do it this way. So, but unfortunately, you cannot do manual correction. So if your segmentation is bad, then it's failing, and that's it. And yeah, Lindsay already covered like the common issue. So now with FreeSurfer, how you run it on CBRAIN. So, but basically, like it is the same thing then with CIVET. Instead of having main, you're gonna have like Nifty file. You can do also this really similar processing for your file before putting in FreeSurfer. And I think the only difference is that in FreeSurfer, you're not gonna choose like each of your Nifty file before launching CIVET. You need to go like in the setting more and you create a file list with like all your Nifty subjects selected. And then when you're gonna launch FreeSurfer Recon, like you need to select your list, the file list only, not the Nifty file, and the FreeSurfer license, which you don't need license in CIVET, like only in FreeSurfer, but you can go like in the FreeSurfer website, you just put your email name and they're gonna give you a license. So, but you need to put this license also in CBRAIN if you want FreeSurfer to run. So you choose like this 2 files, and then you launch FreeSurfer Recon All. And the parameter, I think the one by default work well with FreeSurfer. Generally, you don't really change that. At least you are really, really specific thing you want to do. So by default, like people choose like all, like you process like the full processing run. And you can also add like specific module, like if you want like specific brainstem structure, so you can choose them in the segmentation module, or like specific hippocampus or amygdala structure. You can also add it like in CBRAIN. And it's gonna take around like 6 to 10 hours. In parallel. So, and it's gonna produce like output like recon all cross-sectional output, and you can download all your output via the SFTP also provider, the same way you import your file. So for the quality control, I'm gonna go really quick over it because it could be like 2 hours only on the quality control for FreeSurfer. But really quickly, if you want to do it, you need to use
Can you hear us outside? Echo. Turn this one.
Yes, but big echo, a lot of echo. I think 2 microphones are working now.
Is this better?
Still with some echo.
Okay, well, let's gonna stop this for now. It's possible to hear. Yeah. I can't turn off the audio for the room at the moment. You know, I have it set. this better? Can you hear me outside?
Yes.
I could put it into the chat. Okay, perfect. Thank you. So they can hear us now because I'm using the microphone through my laptop. They can hear outside. If you could type your questions into, are there any questions from the outside? We just went through kind of like a quick check through the people in the attendance here in person. Are there any questions for either Lindsay or Christina? I know there's one that I saw mentioned earlier in this chat about plugins. We'll get to that one in a second, but actually, let's go through that first one. Question from one is saying, can you develop tasks or plugins that are more based on NiPipe? Is it inside the Rail structure always, or can you develop an Apptainer app? So it's more of a CBRAIN question. So an Apptainer app. So yes, anything are Apptainer containers, they can be incorporated into CBRAIN. Even the CIVET is a container within CBRAIN. We just then correspondingly have to add a boutiques descriptor so that then generates the web interface. So we have online documentation about that. So anything that can be containerized, we can essentially bring into CBRAIN. So that was the one typed question. Are there any other questions from outside? If you could type them in the chat, just like, because right now a bit of the audio is, or you can try speaking and I'll turn the mic back on if I can figure that out. So the mic is back on. Stay here. Okay, so they should be able to hear, or at least the response for that question.
You may get good chances with NeuroCivet, which is separate two which specialize specifically on neonatal imaging.
No, Claude, do you have anything to add? But NeuroCivet, if that wasn't heard, I wasn't sure if that might have been picked up from the microphone here. Do we have, I can remember, do we have NeuroCivet in CBRAIN? Yes, okay, we do. Great, thanks for that. Are there any other questions from the audience outside? I think I've got them from there. Let me just quickly scan. Okay, we're a little bit behind. So we'll take a quick 5-minute break here, and then we'll try and see if we can sort out the microphone issue, because otherwise we have to navigate a little bit to go back and forth, particularly from the outside. But hopefully you'll see with the hands-on exercises that you can follow along. The people, if you have questions from the outside, we have Pierre on our end inside the Zoom session as well, manning, and we have other people connecting, so they will be able to see your questions anyway without necessarily the podium seeing it. So okay, so we're going to get started again for the hands-on part. So Mai is going to take over. She's our user support documentation and training coordinator here, specifically that works on CBRAIN and NeuroHub. So she's going to guide you through some hands-on exercises to put into practice the things that you learned about from the CIVET side, but on how to conduct those directly within CBRAIN. Not that you needed.
No.
Okay.
Perfect. Well, thank you everyone for joining us today, and sorry again for the technical issue, but right on time, back on hands-on exercise on CBRAIN. So I hope everybody is ready for that. So just a quick overview of what you're going to go through. So first, if you don't have an account, you can create an account, registering to the account with the link that is provided. So for the purpose of the workshop, we're going to use open data that has been found in OpenNeuro, which Bryan quickly explained a little bit at the beginning of his presentation. And the dataset is already ingested in CBRAIN for the purpose of the workshop, so you don't have to worry about that. But obviously, like Christina and Lindsay mentioned, you can upload your own file, and there are more documentation on our NeuroWiki page if you have any questions. Then, because the dataset is basically a bunch of bit subject, we're going to use a tool, simple file extractor, to extract the nifty file from 8 subjects. Then we're going to convert the NIF file to MINIC using the tool in CBRAIN. Then we're going to go through quickly on the visualization with Bryan browser to see the MINIC input file. Then we're going to run CIVET. Well, when I say we, you're going to run CIVET and monitor the task, and finally visualize the output. This is the link if you need to create an account, but I think everybody has an account or demo account. If you have an issue, please let us know by Zoom or physically.
Log in, either guest account or.
Perfect, so we're ready to start. So when you log in, you're going to create a project. This is the first thing you're going to see. You click on Create Project, and then you're going to pick a name that is relevant to you.
Just a quick note, when you were guiding people to, when you logged in, you're logging in that link there. That was the NeuroHub one. If you went in through NeuroHub, you'll have to click on the CBRAIN button at the top left. This is the CBRAIN view. You can clarify afterwards the difference, but you can either go through directly to the CBRAIN portal, which is what you'll see here. Or if you're going into the NeuroHub side, you will just have to take an extra step of clicking on CBRAIN. I just want to clarify that.
Thank you, Bryan. Yes, you can easily interact between NeuroHub and CBRAIN interface. So we are in the CBRAIN to create a project here. So pick a name that is clear and relevant to you for the project, and add a little description. So here I just put like training, workshop, hands-on exercise. Then you click on Create. Then just going through the Open Neuro page that Bryan mentioned. So for the purpose of the exercise, I select a data set named Game of Thrones for any fan here. So when you go through the Open Neuro, you click Analyze, you will see a view on CBRAIN. You click on it. And because in CBRAIN, I already integrated the data set, you can just switch to project once you're here. But as well, if you look at the project, you have a different bunch of tabs. You have a private project, shared project, and public project. So this specific project is available in public project. Then you click on it. You will have all the data sets available from the Open Neuro. And you just select the file that you want to extract. So for the purpose of the exercise, I selected 8 subjects, like you can see here, 1, 2, 3 to 8.
This is a checkpoint. Are people able to find that particular Open Neuro data set within the list of public ones? You also have a search box where you can type it. But sometimes many of the public data sets are very numerous, right? So then you can actually scroll. But from that, you can be able to then click on the actual data set and see the content. Is anybody not able to get that set? Well, we show an example where we started at the Open Neuro site, but in this case, it's already pre-configured in CBRAIN. So you just go into your portal, and you should see it under your list of public projects. There's already no. So in case as Bioshine, can you go back to the page? So it's data set. The one that she was particularly example was data set 4840. So if you just search in the list.
DS 004848.
see the contents of that data set. So that's exactly it. So what Maya was emphasizing is the fact that sometimes you'll know in OpenNeuro what data set you're interested in. We already have a link there that brings you to CBRAIN such that that data set will then become visible within CBRAIN. So many times you'll get a lot more information on the OpenNeuro site about that data set, all the details, its history, its structure, all those pieces of information. That's the ultimate source of truth for those. CBRAIN just facilitates the access to Caron. So that's why she started with the OpenNeuro site and then brought CBRAIN. We just saved that step of configuring.
Thank you, Bryan. So now that you're like in the data sets and then you want to launch the tool, simple file extractor, you select the file and then you will find a little box on the top, launch, easy. You click on it and then you're going to have like a select tool where you select the tool. You can search by typing the tool that you're looking for. Simple file extractor. We also have different tags if you want, not sure what you want, that you can select. And then you have to select the version and where you want to execute the tool. For the purpose of the workshop, we selected Converter 2, but just to let you know, it's just to use if you want to run a very short task and that's not going to take too long, or for like a workshop purpose, so testing. But you have many other different execution server that you can use. And then you're going to choose the version as well. Then you click Launch Simple File Extractor, which is at the bottom. Sorry, you can see it on the screenshot. Oh, sorry. Okay. Here, and then you're going to have like a tool. A new window that's going to pop up where you will have to set up your control parameters. That was explained very nicely by Christina and Lindsay. Here you're going to have to select where you want to save your results. Here I select main store. You're going to select the project where you want to save the results that you just created before. You can add a description. So for you to remember in the future. And then here, because as I mentioned, CIVET only take MINC file and not bits data. And then because, as I mentioned before, the open data set has a bunch of bits subject, we needed to extract the NI. So that's why you need to enter the extraction patterns. So in CBRAIN, you could actually click on one of the subject control, like for example, subcontrol 1, and then it will give you a display of the content of the directory where you can actually see the path. So for the purpose to run CIVET, we want the NI, we want to get all the NI. So this is available on ANAT, and then this is the extraction pattern. Then you will have to enter the output name, which is mandatory. Otherwise, you're going to have a small error. And you click Start Simple File Extractor.
Okay, let's just go back maybe step 9, let's get everybody synced up on the step. So for people, you've been able to identify in the list of the data set, right, the actual bid subjects that you're going to want to extract the nifty files from, right? So you checkbox those. And then when you do the selection of Converter 2, which is really a very quick, short processes, right? Select that tool for the extraction. You should get to the control panel. Is everybody able to see the control panel? Right, and you're setting the parameters at the top for how CBRAIN will manage the data. So the main storage is where it stores it in the CBRAIN system. And then you're going to specify the project because you can have multiple projects, right? Working on multiple things, different topics at the same time, probably. So you're going to select a project that you created at the very beginning. right? So this is the example name of the project that I created. Right, but you'll want to specify from the drop-down menu project that you yourself created. That'll be the destination for that output. Does everybody achieve this step? Perfect. Thumbs up. Thumbs up. Perfect.
All good. Easy. Well, then now the tasks are launched. If you have launched the task, and they are created in the project of your selection. Because now we switch from the open data project to your project where the tasks are launched. Then now you have to go back to the project where you run the task. Then you can use the quick project switcher that's on, like you just click on it and you select the project where you want to go. Now you can go to the task where that you just launched. You will see the name of the task mentioning here. And once the task is completed, you can check the current status. You can go now to your file to get the output. And the files are available pretty quickly on your file.
Is everyone able to see and get the green bar at the top when you did the submission? So it should show you the extraction, and extraction should look pretty quick. You just refresh the page, then you'll see them. You'll see them nicely go from a state change. You'll see them from new to running, then done.
Everybody okay?
Full file extracted failed unclusted as a message. I don't know if that's. So I did have the green, but then later I refreshed it, it's fine, and I see messages change. I don't know if that's related. Yeah, what created the project? That's your project. Yeah.
Anybody else has issues to run the task? Is okay? I'm sorry?
Stuff that's new, it hasn't changed over the time.
Okay, so you will have to be patient.
That might be because also there's only a certain number, depending on how many people are submitting extraction tasks at the same time, right? If there's like just a handful of you, then it would all run concurrently. Depending on how many are there, then it could be.
Is this the right? I forget.
You go back on the slide to where you show the pattern of the extraction.
Yeah. Patterns should be star /
That's probably why.
Yeah, Star will do that. Yeah. So that way you want to be able to look for every file or every structure there inside.
Yeah, that's probably it. Thank you.
You have to do it in open. It can be, that's just an example, but it can be whatever output that's sensible to you for your particular.
And then I refresh.
Is your task still new?
You have to switch that.
Yeah, it's still.
Okay.
Can I say something?
Sure, Pierre. Yes.
Okay, I'm monitoring what's happening, of course, on the CBRAIN server, and many users have launched the conversion jobs not on the supercomputer or the execution server called Converter 2. They launched it on Beluga. So this is the reason why if you launch your task on Beluga instead of Converter 2, it's taking a long time. Converter 2 is the one that is under our control and is prepared for the workshop to be to be available immediately, whereas Beluga is an actual supercomputer with, shared user space. So it's likely that this is going to take a lot more time if you did it on Beluga. Just wanted to point this out.
Thank you, Pierre.
One more note.
Yes.
I just want to say that this demonstrates as a side effect that CBRAIN is really a distributed system where the data can be anywhere and processed anywhere else, and it does automatically the copying and the transfer of data files as needed without the users having to worry about this, doing any kind of copying. The users who selected to process their files on Beluga there, CBRAIN just started copying the data from Open Neuro dataset in the US all the way to Beluga and doing the transformation there. So it's like an abstraction that makes everything transparent to users.
Thank you, Pierre. I'm sorry, I don't think the people in the room were hearing, but I hope everybody else online have been able to catch Pierre comment. Does anyone online has issue, or most of people have been able to run the task?
Because it happens when you share someone actively in brainstorm, and then just like they kind of scratch, then finish it, and then what's happening. And because I have no space that brainstorm, and I have to redo it all over again. So, yes. Yeah, so every time it's gonna finish. When the dream is good, it's great.
Try it again, so I switch the data set.
So does anyone in the room has been able to run the task and had results? Yes, thumbs up. Great. Not yet. Some. Yep. I'm just checking if anyone has able. So we have 3 thumbs up. Yeah, sure, of course. This one?
That's fine. Anybody else has comments? Ready? You'll see that particularly when you get actually running CIVET, because it won't be running enough slots to that are running at the same time. So you'll see some
But in practice, I would
not this particular task, these quick ones, you can run directly on the internal server, well, conversions, extractions. Running CIVET, FreeSurfer, absolutely need to run it on
But then that is.
Or the basically line system. Any of the line system. Because that will take like 5 to 7 hours. Depending.
Yeah.
And subject and how many subjects you're running.
Okay. Is there an option to run it locally or does that?
No, the idea is that you wouldn't want to. Because otherwise.
Oh.
And you can just select everything, select everything you want, and
It's a little bit more complex. The easiest thing is that you have to save it to your own project and main story. It's only you that it's accessing.
Like a private.
It doesn't even by default, if you create a project now, it's not going to be shared with anybody unless you explicitly have. And those are the special cases where you can figure out compute to be visible to them. So, normally for nowadays individuals, your own project is sufficient for what you need to do. If you have a lot to do, that's for sensitive data. Then we configure potentially your compute server and your compute storage. Inside that server, so that it stays sequestered in there. And just because it's connected to CBRAIN doesn't mean anybody else. Right. Just designated people. But chances are you don't do that. But
I don't think so. But I'll find something that's clear. Okay, thank you.
Okay, so I think everyone
It's good.
gotten to the stage of doing extraction. Is that
This is where we are at, yes. So now that your task is completed, hopefully, you will get the output file available on your file. So you click on it, you click on the file collection, then you're going to have a new table that's showing up with the list of all the Nifty files available on the file collection. And now you want to extract that file from the collection. Just click on it. And then the 8 files are successfully extracted, as it should be. And the 8 files are available on your file in the correct in the project that you created. Does everyone has the 8 file? Good, great, thanks. Okay, now that we have the Nifty file, we need to convert to the Mink file. So we're going to use another tool in CBRAIN, Need to Mink, conversion of the Nifty file to Mink file. The same process that we went previously. You select the file that you want to convert. You select the tool, Need to Mink, same thing. You're going to select the version, Converter 2 or Converter 1 for quick results. Then you launch the, you click on launch. Then you have, again, same process. You're going to have the task control page where you will have to select where you want to save your results. Main store, we recommend. You select the project that you created, because you might have a bunch of different projects in CBRAIN.
Yes.
Huh?
Listening to it.
For what?
Here. Oh, here. I'm listening to that.
Oh, you're listening to that.
He's
Oh.
trying to figure out.
Okay, sorry. Then you can see the list of user files that have been
Do you know
selected.
what they're saying? They're saying you sound like an owl.
Can you
Sorry.
hear me?
They're saying that you sound like an owl.
Then for the purpose, it's easy. You just for the voxel conversion parameters, you just let the program choose. Same thing for integer, you let the program choose. And you click start. Everybody has been able to launch the task. Yes?
So you'll be going through the same steps as you did before. You'll see the same sort of menu where the top half, the top part will show you the CBRAIN orchestration control pieces. Set the project, you set the output storage locations for it, and then you set the parameters, if any, for file converting. And then we'll launch at the bottom.
So the tasks are now available on your. Oh, sorry.
The setting page.
Yes.
Just to clarify. In this case, the parameters we're just setting for these are just default and default. You just let the program choose.
Okay. So now the task have been launched. Depending on the time, should be well completed or not, or running or pending. Well, as long as it's running, it's good. Once it's completed, you will see in the current status, you will see the file available in the files like previously. So all the MINC files are available in your files. And then to visualize, if you want to visualize the input, you click on it. You click on the main file you want to visualize. A new window is going to pop up. And then you just change the view to volume view. And then you will see a very nice scan.
With your cursor, you can drag and go through the different layers. You'll see, so it's interactive. You can work interactively as well. And you see the corresponding voxel and the coordinate values changing as well. And you can also even change it from the grayscale to spectral scale, so depending on what you're trying to look at things. So that's all directly within the world.
Okay, now the final step, the one that everybody's waiting for, is to run CIVET. So I would recommend everyone, for the purpose of the workshop today, that you select one subject. I already ran the task, so I did on all 8 subjects, but it might take more time if you do all of them, but feel free to do it on your own time or even now if you want, but it might take more time. So just select the one, the subject that you're interested to run. You click launch, like previously, same process. You select the tool, CIVET, the version, and you launch CIVET.
As mentioned there, what Maya was showing is if you wanted to actually launch it on all, say you had all of those 8 subjects in your data set, you could launch those. Again, given the long amount of CPU time that'd be involved compared to the other steps, right? You would want to run these on the HPC side. So it's like Luca, Graham, Cedar, for example, right?
Yes.
But in this case, you can run it on converter 2, but just pick one subject. Okay. In the end, we're gonna that way you'll see the state of it running. But Maya will show you. She'll jump to the end because she already pre-processed these particular subjects for this data set. Okay. So don't pick all 8. But this just shows you by one click, you can, instead of having to run each of those particular input files separately, you can with one click have them all processed through one workflow that you're doing.
Go to Bryan.
Okay, so now that's the CBRAIN part, but then she'll go through now the details of the parameters, which Lindsay talked about, Christina talked about.
Yes, so the parameters, you're going to pick the one that's best suited for your case. Same thing as before, you will have to save your results to like here in main store, select the project where you want to save your results. You will have to it's mandatory to put M3 distance. I think Lindsay and Christina mentioned that. For the task that I run, I use 150 for some reason. Might not be the best, but it worked. And then you're going to put the prefix and subject ID. So I did manually. For some reason, I only had 8 subjects, so it's easy. But like, let's say you have thousands of subjects that you have to enter, you can actually use the convenience of prefix and subject pattern. You just, like, let's say if you want to call the prefix my study, you would type my study in prefix pattern. And the subject ID pattern here, it's actually, the subject ID name is control 01, control 02, blah, 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 and 8. Then, as it's mentioned at the bottom of the screen, you don't have to type the name, but you can just put in brackets 1 or 2 or 3, etc. Here it's after the dash, it's control 02, so it's the second one. So you just type bracket 2, and then it's going to pop up and automatically write all the prefix and subject ID. So you don't have to do it manually.
There's a link in the bottom. You just go back, Mike. It's you can just maybe just let them know there's a toggle. They may not hear me well. So toggle explanation, where you read this on the bottom. That gives an example of how to do that repopulating based upon the patterns. But you will not have to set any of those patterns, but if you pick one subject, you don't need to set the pattern.
Thank you. Well, if you have a question, of course, we can clarify after. Then now it's just, the task on launch, and then now it's time to monitor your task as before. It's going to take some time before your task is completed. But 1 or 8 tasks have been created simultaneously. And until it's completed, once it's completed, you can actually visualize the output like we did for the input.
Maybe let's just do it. It's a check to make sure people know where they're at. For people able to select the one input file, set the parameters. Yeah, go ahead. But can you go back?
Oh, sure, of course. Sorry. Here?
Okay, can you explain the preset management? I know you cannot click on show hide there, but on the left side, preset management. If you click on that, it's fine.
No, that's maybe go to the browser if you're logged in. Sure.
Because this allows you to save your parameters. You ran only one subject now, but it saves your parameters. And the next time you go in, if you want to run the 7 other subjects, you can just reload your config file for the first subject and apply it to the other subject and rerun. It's very convenient.
Maybe just for the people outside, you can repeat what the code just mentioned, but presets, be quick. Preset management afterwards.
Yep, here.
So then if you see there's menus there for load a preset configuration, save. So you get that way everything is saved. You can then, if you've done one,
Oh, right.
apply it to all the others.
I don't have a preset.
Well, in your case, you don't,
Okay,
but
sorry.
you can create one
and
reload it.
Yeah.
That way it's easily retrievable.
Thank you, Claude. Sorry, I missed that. I didn't have a preset.
Okay, so everyone was able to see the task launcher. So mine's not going to take you to the next open examination though, because this will take around 5 or 6 hours to run. Right?
if you have time.
I don't think you want to be here for 5 or 6 more hours, even though you could go away and come back. But she's gonna walk you through an example now because you pre-ran it, so now you're gonna see what the output looks like. So all the elements that were generated upon output mentioned by Lindsay and Christina will be able to examine.
Yeah, actually, I can show it to you from the CBRAIN itself, which is the same thing as the slide. So for the purpose of the workshop, I saved the output in a different project that is public. So you can actually go to the public project and look it at yourself. CBRAIN NeuroHub Workshop 25 output. And then you can see in the Files tab all the CIVET output available here. So if you want to visualize like the input file that I showed previously, you just click on it on one of the subjects that you want to visualize. And then you will have all the CIVET output content, and you can expand the directory. Like as an example, I went to final folder, and then there's a subcontrol final MINC. I click on it. And then if you scroll down and be patient, you will be able to see the scan. And as Bryan mentioned, you can use your cursor and then move.
And in terms of the other, but maybe we scroll back up again just for a moment. So for some of the metrics of some of the outputs that would be generated, for example, the thickness and quality control.
That show displayable contents. It's about the right, the red line.
In blue, so we look at just above the red.
Oh, here, sorry.
One up.
Oh, sorry.
So this is, there we go. So we see there.
Mai, can you hear me?
That were shown by Lindsay and Christina as examples. Those are generated, so you can see them directly. You don't have to download them to your computer. It's all directly from the browser within CBRAIN.
Could you please repeat how to get this page?
Yeah. Can you
Yeah.
get this backwards? Oh.
Mai, can you hear me? Hello?
So for the rest, actually you go to the file and just under change view, you can click on show displayable contents.
Be able to navigate to that.
And same thing, you just expand any folder that you're interested to, and then you can click on any blue link and visualize directly on the web browser.
Mai, testing
Here's
again,
just
can you
mentioning,
hear?
you go back to, so for example, in the change viewer, can you select and change viewer to surface viewer?
Right.
So that'll let you see the surfaces there as well. Pierre just mentioned that.
Oh, sorry, Pierre.
You can't see it.
No, yeah, sorry, Pierre.
Can you move the brain a little bit to show that it's live?
Yeah, you can rotate it. So you can see the color significance that was mentioned depending on what was mentioned by Christina. Lindsay earlier, you can see the different levels depending on the region you're looking at. Go back maybe just to the content list. You switch I to the. So all the outputs includes things like the thicknesses there, the directory. So those are produced in text files, which you then, I think those elements then, I forget the name that Christina mentioned and mentioned about the secondary tool for analyzing.
There's search stat.
as well. So those would be taken as input, take these value 5 as inputs, for example. These you would download, right, to your computer to then pull into Search Center. When they get those, you can either download them directly or you can even do an, my sees shows at the bottom screen, there's an extract files as well. Depending on what, you don't have to do one by one, you can tell it to extract specific multiple at the same. And all these specific processes that was done, this is also done, as mentioned before, by Lindsay in terms of the HVCD data set, but particularly the UK Biobank, these we've already pre-processed. So for example, you would not want to say, if you have, as part of your project activity, working with UK Biobank, want or need to rerun CIVET. Those have already been executed, and those are already outputs that we've pre-produced already, and those are accessible as outputs as well. So it saves a lot of CPU time by looking at what may be already pre-processed.
Are they QC?
They have been QC by, I know, some Mallory Chakravarty's group at Douglas. They did a manual QC of that, and they've uploaded into our repository the outputs from their manual QC for that. We describe that on our wiki page. That's okay, I think, for the development line.
Yes, correct. Yes.
And let's try again how.
Which, oh, sorry. Yeah.
Switch to Surface
Surface
Viewer.
Viewer.
And that directly uses this Brain browser, an application built in directly within CBRAIN. It runs SAML for other applications that we have as well. The Brain browser will let you do that visualization directly.
Can you see it?
It rotates. Are you able to see it in there? Yep, should be fine.
Oh, it's probably special.
It's on.
That
What browser is?
oh, that's not.
Oh, nice.
Reload the page. There we go. You just have to reload the because it pulls down copy. There.
I just want to ask, I only have access to the pre-process. How they.
You don't use the RIP is a separate service that they brought online for exclusively for that.
Okay.
We have an application where we're already we did pre-processing all this and stored in our instance. They can access from CBRAIN or directly on right.
And
so you can't access it from the RAP. The RAP doesn't do the pre-processing. They're behind in the neuroimaging tools compared to the HBC.
So like what I just
He looks now.
If you've already registered with us, or have you already registered with us?
but
I mean, as part of the UK Biobank.
I'd have to.
Yeah, so it's not a public project because it's controlled access. So you have to register with UK Biobank under our application, because we can give you links to afterwards. Then once you sign in, then you can access all the data that we have through the process, either directly on Luga or directly through CIVET. So you just need. What is your name? This is the just conversion. Yeah. No. But yeah. So your browser accelerates. Go on. Getting started. Let's see. Not yet. So we have the step there. This is where we register the bank itself. Join our application. Okay. Yeah, that's have all the settings and see where you go next. So just follow the step by step on this page. You'll be ready to go. It's the one, Mike, can you re-show the project name?
Yes. Sorry, CBRAIN, CB and H workshop 25 output.
Yeah, the one without output is the input data that she marked it output. So that's what's created by all the CIVET output for those eight files.
Everyone in the room has been able to see the one output at least? Yep. Okay, well, I think that's pretty much it for the exercise today. Do you have any question? More question? No question? Well, it means that everything went well then. Been able to run your task, which was the purpose.
Questions? Maybe if there's any questions from outside, surveying.
Question on Zoom?
Can you hear me?
Yes.
So no questions. I've been keeping an eye on the chat, but I can see that there are 11 CIVET jobs that are running right now on Converter 2. Like explained, this will take several hours to run. For the people who are using demo accounts, we're planning to destroy them very soon, of course. I suggest that you get a real CBRAIN account instead if you want to see your outputs. We'll probably terminate the jobs, but for the people who are using their own account, the output will be available for you to look at in a few hours.
I think we can go to the last slide, Mike.
Well, that's the last slide is just a small post-workshop survey. Please forget the technical issue that we had at the beginning. But we almost finished on time and we still have some drinks if you want. And if you can take a few minutes to complete the survey, that would be great. Today or tomorrow, that's good. Otherwise, we'll have a second workshop. So hopefully we'll see you soon.
Yeah, so everyone, thanks, Mai. Just as a reminder, the survey link you'll circulate to everyone to attendees afterwards as well. So either you can fill it out now if you want, or you can do it afterwards when she sends around the link. Again, apologies for the delay at the beginning, but hopefully you can see then, the information about more in depth that you saw about CIVET from Lindsay and Christina, right? And then follow-up questions that you might have had and spoke about with Claude. And you can hopefully then see, obviously at one point I didn't really emphasize